So, again, everywhere we go, everything we do is based on communicating to some server or to some person around the world, right? So network is part of our lives and it's part of everything we do. If you think about you surfing the web, you need the end network, you need the internet, whatever you want to call it. If you're on your phone, you're going on Instagram, Instagram needs to connect to these servers. You're chatting with your parents at home, well then it needs a network connection. There's barely anything left that doesn't use a network, and we need this because it's the way our our culture has developed, where we're in need of something that communicates the world, that connects the global world together. And if you ever make a new application, most of the time, uh, you would basically have a connection to some sort of network. So I got a question before we move on further. For the project and or final exam, will all this be tested in threads networks? For the quizzes, there might be questions about threads and networks. For the final exam, I haven't written it yet. Usually, I wouldn't have networks in there. Threads, neither. But we'll see how far we get to, and I haven't written the exam. So network for sure it won't be in there because I can't test out your network other than on my own PC, which is okay, but it's too much time for me to get started. But for threads, there might be a chance. Okay, so in the end, forget about what's gonna be on the exam. Focus more about what's what do you need to improve and further along your skills in management. Okay, and it's already been 15 minutes after the break, so you'll notice some people are still missing. Okay, let me take a screenshot of this actually. Okay, back to networking. Uh, so networking is really important, and we need to be able to do this. But to understand how networking works, we need to kind of um, kind of understand the overall picture. And I really can't go too much in details, but we're going to talk about a few things that's going on. The first thing is, let me get that annotation up. The first thing is, well, we have a PC, and let's say this is our PC. And let's say other people have PCs too, so forth, so on. Okay? And let's say these two people, they live in the same house or same apartment, whatever you want to call it, or same building. And this guy is, let's say, somewhere else, and this computer guy is in, well, let's say this is the server somewhere else again as well. Um, let's say Chicago, whatever it is. Okay. The first thing, how do we locate other people? So if this guy and this guy, actually before we do this one, if this guy and this guy, they wanted to talk to each other, how would they communicate? Well, this is where IPs come in. So the same way we have addresses, right? When you want to email to someone, you would have an email. Let's say actually email. Whenever you want to mail something or go to someone's house or to communicate with someone, you could either use their phone number or go to their place directly by having their address, which says something like this. Let's say 2345 St. Jack Street, and you gotta say province. It's in Quebec, it's in Montreal, it's in Canada, and if eventually we go on space conquest and whatnot, it will be on Earth, right? The more detailed your address is, the more understanding we get. This is a really important thing. So this address that we're seeing at the end here, it keeps on becoming, actually let's put this one before. It's becoming more precise. So we're saying in Earth, in Canada, in Quebec, Montreal, and St. Jack Street at house number 2345, it's where this guy is, or where this guy is, right? We do the same thing inside computers, but we use something we call IP addresses. Right? And you should have seen something. There's two versions of IP address. Let's talk about that for a second. There's a v4 and a v6. Now, IPv4 looks like something like this. Okay, you've seen it, whatnot. And IPv6, it's really it's really long. Okay. Now, IPv6, we're gonna ignore it for now because that's not the goal of our course. Okay, but we actually, first of all, IPv6. Damn it. We got to IPv6 because IPv4 we ran out of addresses we could put. Right? Inside Montreal, if we ran out of address, well, we need to create a new street to be able to put more addresses. Or we need to convert a house into an apartment to have more addresses. Well, this is the same thing that happens inside IPs. So IPv4, this part, this part is the closer version you see here. This is like the 223.45. This part would be the Saint Jacques, Montreal, Canada, right? Again, we're going in subdivision. The more we go precise, the more these numbers go down, the more precise we are to the house. And this is kind of like that. Okay? So for us to communicate from one computer to another computer, we need to know what their address is. In this case, we need to know what their IP address is. And then we could talk to them. And a lot of times, you would see something like this. You would type in www.google.com, and you're like, well, I'm talking to Google, but that's not an IP address. Well, having IP address is a bit hard to read. So rather than having an IP address, they they convert it for you into this word thing that you see here. There's a naming for it. I forgot the naming. I'm sorry. So this translates into a specific IP, and depending where you are in the world, this would translate into different IPs because they have multiple servers that point to the same thing. How they do that and whatnot, it's not the point of this course, but it's a really cool thing to know. So if we were to go on our command prompt, CMD here, and we would say, let me go back on my mouse, and we would say, let's say a ping to www.google.com, you will notice that the IP shown, if you look at the IP shown, it's 172.217.164.196. So that google.com translates to its IP, which is 172.217.164.196. Okay? So that's the first thing. So for us to communicate to each other, we need to have the IP address, which is important. The second we need to communicate with each other is the apartment number. So if you look at this house, these two computers will have the same exact IP. So this one, well, let's say it's, I'm putting random numbers here, 182.661, right? This is the address for this one, and this one is also 182.6.6.1. So both these computers and the same apartment have the same address. Now, how do we know which one is communicating with which one? Well, that's the job of your router. Depending what signals you send out, signals you send in, it'll determine it with a bit more precision than just the IP, okay? It adds a bit more data. But the house, it's always going to be the same address. So whoever's in the same room right now, if you check your IP with your friends, you should both ping the same type of IP. But inside of a house, there's a second IP to differentiate all of those devices you have. So there's a house address and there's a worldwide address. So even though this house to the world is 182.661, inside this one is 192.168.1.1, and this one is 192.168.1.2. And again, I'm putting 192.168 because that's a reserved indoor house thing. So if we look in, let's say CMD, IP config, you notice my IP at my house right now says 192.168.12, right? But this is not the address that the world sees me at. This is the address that currently within my area, my local area, this is what people see in there. Okay? So again, we're not going to go too much in depth, but just understand that the house address is not the same address as outside. So if you wanted to know your address outside, the easiest way for you guys would be to go on Google. What is my IP address? And you'll notice that my IP address is not what I was shown, right? And now I need to change my IP address because someone might just hack me. Anyway, back to this. So knowing that, that's perfectly fine. Next step. Now that we have this, we know the address of where people live and whatnot, you'll also notice that inside of a computer, we don't have only one application. We have millions of these applications. If I run my task manager here, you'll notice I have Google that's connecting to hundreds of websites. I have these other applications that are also connecting to these other servers and whatnot. And a lot of them are connecting right now and talking to them at the same time. So how do we differentiate the lines coming in? This is the second part. Let me take my text. The second part is ports. So within that same computer, if you could think of it as the Montreal Island, actually let's see if I could get a good Google picture. Ports. And let's go on images. So if you look at, let's say, a good example of this gives you an idea. Sorry for the image here, just give it a second. It's not showing it really. This is a good one. So if we look at this, you'll notice there's a lot of these water path openings. These are specific port numbers. So whenever a boat comes to our city, they are assigned a location where they could come and put their boats. And when they go back out and they come back, they will get another port or the same port. Okay? So a port is a location where the data is going to come in from. And we did the same thing inside computers, where we said we're going to assign ports to those IP. So when someone's communicating to my address, they're going to also specify a port, and that port is going to determine what application it was. And this is a really important one. So inside my text here, I would always have the same IP. Let's say my IP is, let's say this 182.661, but I will also mention a port, and the port is important. So that colon here is mentioning what port it is, and I would say I am port 256. I could say 182.661, I am port 9863. Now, when you see that the two ports are different, this means that I have one application that's communicating somewhere that's using port 256, and I have a other application that's using port 963. So all the information coming in and out will tell me which port it is, so I could keep track of that. So my computer could understand that this information, these ones and zeros coming in, is for this specific applications, and I'll give it to that. And these ones coming in is for that application. And you'll notice, even though you're not typing in when you type in Google, actually, we did a couple of things. We might as well test it out. So if you remember, first thing we did was we figured out what's Google actual website. So here, if I do ping.google.com, we notice it's 172. There we go, copy this. It's this, okay? That's the website of Google. So if I type in this, it will go directly to Google. See that? Now, Something else you don't notice because they do it without telling you is that this websites are actually using the port 80. So again, if I type this, I should still go to Google. Okay? So the first thing we need to note is because we use so much websites and internet, that the port 80 has become a reserved port. So port 80 is reserved for internet. And to be honest, a lot of ports are reserved. So these are all the built-in application that you have that's already being run by whatever. So either for internet or for this other type, etc. I'm not gonna go through the list, but there is hundreds of these, and because of that, already your early port numbers are all reserved. So from now on, whenever you make an application, you want to be in the 4 digits. So 000, and you could go up to 5 digits. And to be honest, we never went over this number, so these are all the numbers you're going to ever need. And not everyone has 1 million applications, so really we never passed this 5 digits, 4 digits. Cool? So back to this. So we know the address, and now we could determine which application is based off the port, and the port starts out with that colon. Okay, and this is really important. Sorry, give me 1 second. My cat is going meow meow meow. Okay. So inside our programs and whatnot, we're gonna start calling this a socket, where it's a pair of the IP, the address, plus the port. And we're gonna call this a socket. And this is important. So whenever we're gonna create a connection to somewhere, let's say to our server, we need to create a socket for that connection. Let's say I am a server and I have multiple, sorry, my cat's jumping on me. Let's say I am a server, a chat system, and I have multiple clients connecting to me. And in that case, I need to create multiple sockets, one socket for each of those clients. Okay? Any questions? No? Okay. So let's get this going. So I'm going to clear the screen. And you'll notice that inside this network project, you have actually 2 Java files, and you'll notice that both has a main. Where is the main? Here we go. The thing about these 2 mains is it's there so you could start 2 applications. Really, usually your programs would only have 1 entry, right? So I need to first start the server. I'm going to right click on it, and I'm going to say run greeting server main. Let's give it a second. Could say allow access, whatever, it doesn't really matter. So in this case, notice that when I'm starting my thing, it timed out. We'll talk about that in a second. It's specifying port. The port I put is 6435. It's a random one. If your port is already used, you'll get some exception error or something like that. Now, notice that we're also starting this server on a new thread. Why? Because we don't want to lose out interaction and whatnot. So this is going to be on a new thread. It's going to keep on going. And it's going to be using that port. So let's go see that code. So when it starts this, it's going to create a server socket. This is the built-in thing we need to create this connection. Okay? And because we're the server, we don't need to mention the IP because we're the server. Everyone else is connecting to us. Okay? So when we start this thread and this gets executed, the run will keep going. Notice that we're inside of a while true. So while true because it's infinite. We want it to be on stop. While it's going, wait for a client. That was the first thing you would see. And as soon as a client connects to us, we're gonna accept that connection. So it's from the server, whenever that socket got in connection, that port 6435, we're gonna accept it, just connect it to it. We're gonna read some stuff, I don't remember, whatever the client gives in. We're gonna output something to them. Notice we're using the input stream and output stream, but in this case, we're sending it to our server and reading it from our server. So this one is outputting to the server, this one is reading it from the server. Okay, so let's go ahead and change this timeout to nothing, so it becomes infinite. So actually, let's put it to 0. And we're gonna run this again. And notice now our server is gonna be waiting for clients. So the first line here, waiting for clients, and it's on a new thread. It's not gonna hurt us at all. Now, inside the greeting client, we kind of have the same thing. The greeting client, we need to say who's the server. So in this case, I'm using a reserved keyword, localhost, which translates to 127.0.0.1. And this is something you should memorize or get to remember. You'll notice a lot of applications you'll get for your house, you'll need to play around with this, or you could play around with your connections to whatever you need to connect to. So localhost is your computer, or also known as 127.0.0.1. Again, I need to connect to the correct port. If this is incorrect with the previous one, it won't work. If you guys are connecting to one of your friends, get his IP address, put it in here, and then you could see him talk to you. I'm gonna try and do that with our systems. Hopefully it'll be fine. Maybe you guys could connect to me directly and we could have a conversation. So now I press run. You'll notice on my when I create this application, when I run it, on my run I have actually 2 tabs. So 2 applications are being run. One that you see ended and one that's ongoing. Notice it says hello from 127.0.0.1. That's the port I'm talking to that guy. And that client is connecting to my port, which is 6435. Cool? Any questions? And again, the data output stream, we talked about it. Input stream, we talked about it. This is one of the many streams that exist. And now we're talking about zeros and ones. We're not talking about characters. And the reason for that is we want it to be as small as possible so our connection is faster. So it's not doing anything crazy. Right? So now, let's do something for you guys. So actually, let's go on to the other project. It's the same thing. Open recent. I gave you another one which is called socket communication. Again, we're just doing a little intro, but this one is going to be a bit more better. It's the same thing. Actually, was it this one I wanted to? Yes. Okay, so this one I made it so it's like a real chat. So notice I'm putting a different port, again, 4 to 5 digits, doesn't matter, it's not used, it's the early numbers that are used. So here we're gonna run the server. Always run the server. If there's no server, what's the point? It kind of does the same stuff. You can read the code. It's now this time it's trying a resource. If it can't get this resource right away, it would fail. Okay. So as soon as the server is up, I'm gonna run the client as well. Notice that the client and the server are 2 different pages. On the client, I'm gonna write something. Hello, my name is Raza. As soon as I press enter, it's replicating what I wrote. Replicating what I wrote and streaming it out to output stream to my server. So if we go back to our server, you'll notice now, hello, my name is Reza, server received. Cool. So Redam asks, what if the port is reserved for other application? You'll get an exception error. So let's say if we try this and put it 80. Let's go back to our client. We're gonna kill it, and we're gonna run it. So right now you see it got me connection refused, exception error, right? Exception again because it's during runtime. It doesn't know what the port is or if it's being used until the moment it tries to. So this is a good question. Now, if you guys want to connect to my server, you can't use localhost anymore. My server is up. How about you guys try to connect to me? I am not sure about my settings anymore on the computer because I manipulate it a lot. And usually pings are not allowed. What I'm going to do is, actually, I'm going to do it the other way. What is my IP address? So this number over here, I'm going to go inside the client, change that to my IP, and press run. And if everything worked out good, I think I block off connections. But you guys could try. This is maybe internal connections that's blocking. You guys could try and wait 1 second. Let me rerun my server and let's run the client. Might have been just my server went down. No. Okay, I really can't do connections to my computer. I have a lot of security stuff. So if you guys want to try, you could try it. If you guys live together, this would be easy. All you need to do is go on your run, type it, well, your command prompt, let's say. Get your command prompt and type in ipconfig to get your IP address at home. Okay? Now, when you got your IP address at home, well, get your friends, whoever's the server, put it in there, and you could be talking to each other. Usually I do this in class, and the task at the hand would be to write your name on my server and whatnot. But in this case, I think there's too many restrictions, and I don't really care for it to go further. Any questions? So I'm gonna stop the